Hi students, so we now come to the third aspect of trigonometry here, that's trigonometric identities. We have three basic trigonometric identities here. I write them down one by one. Number one is sine square theta plus cos square theta is equal to 1. If you want to learn math and if you want to do anything related to mathematics in your life, this is the most, I would say, not most, but perhaps the most abundant, identity you come across both in geometry and algebra. Sine square theta plus cos square theta equal to 1. Next, 1 plus tan square theta is equal to sec square theta. I'll tell you how it happens. 1 plus cot square theta is cosec square theta. You have to remember just the first one. Sine square theta plus cos square theta is equal to 1, where theta is an angle. Say I draw a right angle triangle. This is 90. This angle is theta. The angle opposite to theta is perpendicular. The angle adjacent to theta is base. The side adjacent to theta is base. The side adjacent to, opposite to theta is P, perpendicular. So perpendicular, base, I have hypotenuse here. Let's see what becomes of sine square theta. Sine square theta is equal to sine theta square, that we know, and sine theta is nothing but perpendicular by hypotenuse. Perpendicular small p by small h, perpendicular by hypotenuse whole square. So I get here p square by h square. This is sine square theta. Come to cos square theta. Cos square theta is cos theta whole square. Cos theta is base by hypotenuse, the adjacent side by hypotenuse. So base is b by hypotenuse whole square. I get here b square by h square. Therefore, sine square theta plus cos square theta is equal to p square by h square plus b square by h square. This is, take LCM here, the lowest common multiple, h square. You have p square plus b square and p square plus b square. The square of the perpendicular plus the square of the base of a right angle triangle is nothing but the square of the hypotenuse, and that's Pythagoras theorem. So from Pythagoras theorem I get here h square by h square, and that's equal to 1. This is from Pythagoras theorem, okay? Pythagoras theorem. And Pythagoras theorem we saw in chapter 6. So sine square theta plus cos square theta is equal to 1. This is the first trigonometric identity. From here, this follows. 1 plus tan square theta is equal to sec square theta. Very simple. What is 1? 1 plus tan square theta. 1 plus tan square theta is 1 plus tan theta whole square. Right? This is 1 plus tan theta is what? Tan theta is perpendicular by base. This we know. So perpendicular by base whole square. This is 1 plus p square by b square. You take LCM here, you get b square, you get b square plus p square, right? So b square means a base square, square of the base plus square of the perpendicular, that's hypotenuse square from Pythagoras theorem. This is h by b whole square. Now what is h by b? We know that base by hypotenuse is equal to what? Cos theta. Cos theta. Therefore, its reciprocal h by b is equal to 1 by cos theta. 1 by cos theta is sec theta. This we know. So h by b whole square is sec theta whole square. This is sec theta whole square. This is nothing but sec square theta. Sec square theta. Therefore, 1 plus tan square theta is equal to sec square theta. Likewise, 1 plus cot square theta is equal to cosec square theta. It's quite easy if you know that sin square theta plus cos square theta is equal to 1. So you have to remember sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. In fact, you have to remember just sin square theta plus cos square theta. Now in problems, what you should do is, in case you get anything like 1 minus cos square theta, you can write in its place sin square theta. It becomes simplified. In case you get something like sec square theta minus tan square theta, this is a long expression, but this is equal to 1. Why? Because 1 plus tan square theta is equal to sec square theta. So obviously sec square theta minus tan square theta is equal to 1. So in problems, if you have these long expressions like sec square theta minus tan square theta, 1 minus cos square theta, or say 1 minus sin square theta, right, you can just reduce them by writing their values in terms of the identities. So in the place of 1 minus sin square theta, you just write cos square theta. It's possible to simplify. Likewise, cosec square theta minus cot square theta. If you get this expression anywhere, you can just write 1, because 1 plus cot square theta is equal to cosec square theta. So that's the technique that you need to deploy when you solve problems based on trigonometric identities. And the fundamental identity here is sin square theta plus cos square theta equal to 1. Once you remember this, the rest of your work is done. So what has happened essentially in the entire chapter pertaining to trigonometry is this. First, we understand what is meant by trigonometric ratios. So you have sin theta, you have cos theta, you have tan theta, you have cosec theta, you have sec theta, you have cot theta. You might be wondering, I'm remembering all these things, I'm memorizing all these things. No, I know only sin and cos. I know only sin and cos. Next, what do I know? I know tan, because tan is simply sin by cos. Okay, tan is simply sin theta by cos theta. So everything is being done by sin and cos. The rest of these things are coming out of sin and cos. Cosec theta is 1 by sin. This is 1 by sin. Sec theta is 1 by cos. And cot theta is 1 by tan. This is also equal to cos by sin. Cos by sin. So everywhere you get either sin theta or cos theta. So just remember sin and cos. So now what is sin theta? Sin theta is perpendicular by hypotenuse. Just remember that. Perpendicular by hypotenuse. What is cos theta? H will remain the same. In place of P, I have B. B standing for base in a right angle triangle. We have a right angle triangle here. This is 90. This is theta. This is base. Base. This is perpendicular, the altitude of this triangle. So b by h. What is tan theta? Tan theta is sine by cos, p by b, obviously. P by b, simple. What is cosec? Cosec is 1 by sine, h by p. Reciprocal, h by p. Sec is 1 by cos. So reciprocal of cos, h by b. H by b. And cot is b by p. So I remember just sine theta and cos theta. Sine theta is perpendicular by hypotenuse. Cos theta is base by hypotenuse. Once you remember these two things, you come across all these things naturally. Then we did complementary angle. Theta, 90 minus theta. 90 minus a, whatever. So sine of 90 minus theta is cos theta, and cos of 90 minus theta is sine theta. Once you know these things, you can go to tan, cosec, sec, cot. Everything is all the same. Then we did trigonometric identities, and here we remember just one thing. Sine square theta plus cos square theta is equal to 1. I remember just this. Right. What you can also do is, you can think of dividing both the left hand side and the right hand side by cos square theta. Let's do it. I divide throughout by cos square theta. So what do I get? I get sine square theta by cos square theta plus cos square theta by cos square theta. I get 1. I get here 1 by cos square theta. This implies this 1 is 1, this plus is plus. Sine by cos is 10. I get here 10 square theta. Okay, 1 by cos. What's 1 by cos? 1 by cos is sec. I get here sec square theta. See, so once I remember sine square theta plus cos square theta equal to 1, I come to the second identity. 1 plus tan square theta equal to sec square theta. Likewise 1 plus, in place of 10 I write here cot. 1 plus cot square theta. This is nothing but cosec square theta. So in trigonometric ratios, I remember in the entire chapter, in the entire world of trigonometry at the level of class 10, what we are doing is, we are remembering what's sine, what's cos, and from there we move on to tan, cosec, sec, cot. Thereafter we come to complementary angles, and then we come to identities. If you are done with these things, this framework, you are done with the whole chapter. At the same time, you are fully equipped to solve all kinds of problems in this chapter as well as the chapter that will follow, which is applications of trigonometry. You have to remember these things based on your trick, a bit of common sense, and then you can apply all these things to solve any kind of problems, right? So in case you have any doubts, any sort of queries, anything more that you want to understand or learn, you are free to communicate to me. You can write in your comments, or perhaps you can use any other online medium to interact and to expand the subject in a way it should be. Thank you so much.